Hey guys, it's Miss Beckham. Today I'm going to review with you Unit 8 Quiz 1. So if you have not taken Unit 8 Quiz 1, this is a great opportunity for you to make the best grade that you can make. If you've already taken it and you haven't passed, then you should watch this video to go over the common kind of corrections by looking at similar problems. So we're going to work very similar problems to the quiz. I just changed like maybe the element to a different element that's very close to it so that you can kind of see examples. And so we will get to those right down here. Before we do that, I need to go through a little bit of prep with you guys on what we're doing for a couple minutes. So this lessons 1 and 2 is covering oxidation reactions and reduction reactions. And so you have to know how to assign oxidation numbers on various elements. So here are the 4 basic rules. The first rule is that the oxidation number of an uncombined element is always 0. So if an element is not combined, like if you have hydrogen and oxygen that makes water, right? Which of these are uncombined? Well, this one is combined, H2O, but this is uncombined, the oxygen and the hydrogen is uncombined. So they both have an oxidation number of 0. So any uncombined element, if an element is by itself, any element, there's 118 elements, but if it's not combined with anything else, it's going to have an oxidation number of 0 with it. The next thing is that for ionic and molecular compounds, an element's oxidation number is the same as its charge. So if you have a periodic table, you need to have the charges written above them on the periodic table. If you don't have one, then take a screenshot of this and refer to it. But all of these elements have certain charges. And so when they are in a compound. So an example of this would be like LIS. Okay, this is an ionic compound. And so the way that we find their oxidation numbers is we go find their charge on the periodic table. So Li is right here and F is right here. So I see +1 and -1 as the charges for them. And so their oxidation numbers would be +1 and -1. But if Li was by itself, like Li plus F, then they would both be 0 because they're uncombined. So only when they're combined together do you find the charges on the periodic table. Let me do one more example. Li3N, okay? So we find Li and N. Li is +1 and N is -3. So the oxidation would be +1 and -3, except if you notice, we have 3 lithiums now, 3 of them. So really, it's kind of like this. There's 3 sets of them, right? And so they total up. The total there is +3, right? So that's a couple examples here, LiF and Li3N. It can be anything. Next, for an ionic or molecular compound, the sum of the oxidation numbers of all the atoms is equal to 0. So you can see that here, +1 and -1, that makes 0. +3 and -3, that makes 0. So for any ionic or molecular compound, the net charge is 0. It's going to cancel out. The first one is going to be positive, the second one is going to be negative, and they are going to cancel out with one another. So that's this one. And the last step, for a polyatomic ion, the sum of the oxidation numbers of all the atoms is equal to its ionic charge. So polyatomic ions are elements that are grouped together. So let's look at SO4 right there. This is called sulfate, right? And these are sulfate. These 2 elements, sulfur and oxygen, stick together like a family. And so we call them sulfate because if it's in a compound like this, it could break apart from the sodium if it was like dissolved. These ions could break apart, but the sulfate, the S and the O, don't break apart from one another. So in your chemistry reference guide, you have a list of common polyatomic ions that are used often. And what that was saying was that these charges don't total up to 0. So Na2SO4, the net charge here is going to be 0. But when you have a polyatomic ion all by itself, it's an ion. It's got a charge. And to find that charge, you can add up the charges on the inside and they will come up to -2 or whatever the charge is. So with that, we can actually do the quiz now, or